So, let's go. You're standing in the solar system right now, and from a distance, it looks peaceful. Orderly. 8 planets, some moons, a few rocks. Everything in its lane. But 9 of the 10 things on this list are happening at this exact moment. Not in the past, not theoretically. Right now, while you're watching this. And at least one of them has already come for us once. Number 10. Hyperion, the moon that cannot be predicted. There's a rule in space. Everything spins. Planets, moons, asteroids, they all rotate in predictable, measurable patterns. You can calculate where any moon will be facing 1,000 years from now. It's just math. The solar system runs like clockwork. Except one thing doesn't. Hyperion is one of Saturn's moons, roughly 400 kilometers across, shaped like a lumpy potato. And it is the only major object in the solar system confirmed to be in a state of total rotational chaos. Not slightly irregular, not hard to measure. Mathematically, genuinely, provably unpredictable. You cannot calculate which way Hyperion will be facing tomorrow. You cannot calculate it for next week. The physics that govern every other rotating object in the solar system simply do not apply here. Part of why is what Hyperion actually is. Over 40% of its interior is void space. It's a rubble pile, loosely packed ice and rock held together by its own weak gravity, so porous and low density that it would float if you dropped it in a large enough ocean. Its shape is irregular enough that the gravitational tugs from Saturn and the nearby moon Titan never settle into a stable spin. They just keep knocking it. Randomly. Forever. When NASA's Cassini spacecraft tried to plan flybys of Hyperion, mission planners couldn't reliably choose which regions to photograph. By the time the spacecraft arrived, the surface would be pointing in a direction nobody could predict. They had to improvise each time. Then, on a close pass in 2005, Hyperion fired at them. A beam of electrons shot out from the moon's surface directly into the spacecraft. Cassini's instruments recorded it. A strong negative electrical charge had built up on Hyperion from Saturn's radiation environment, and when the spacecraft got close enough, the moon discharged it like a cosmic static shock. The only probe to ever visit Hyperion got hit by a particle beam on the way out. A moon that tumbles without pattern, that nobody can predict, that shot a spacecraft with electricity. The clockwork doesn't run this far out. Number 9. Pluto's beating heart. Before July 2015, the scientific consensus on Pluto was simple. Old, frozen, dead. A heavily cratered ball of ice at the edge of the solar system, too far from the sun for anything interesting to happen. Scientists weren't even sure what they'd find when New Horizons arrived after 9.5 years of travel. The smart money was on a boring rock. The very first high-resolution images proved every prediction wrong. There, on Pluto's surface, was a heart. Not metaphorically, a literal heart-shaped feature over 1,000 kilometers across, so bright it was visible from space. And it wasn't just a marking, it was moving. The western half of that heart, called Sputnik Planitia, is a vast plain of nitrogen ice sitting in a basin 3 to 4 kilometers below the surrounding terrain. The surface is divided into polygonal cells, each one 16 to 48 kilometers wide, that slowly churn like a lava lamp. Nitrogen ice heated from below rises in the center of each cell, spreads outward, cools, and sinks back down. The full cycle takes somewhere between 500,000 and a million years. The ground on Pluto is in motion. It has been in motion for a very long time. At the shoreline of this nitrogen sea, there are mountains made of water ice so cold it behaves like rock. Real mountain ranges, some reaching over 3,000 meters, frozen hard as granite, at negative 230 degrees Celsius. And floating on the nitrogen plane between the churning cells are chunks of water ice that have been carried, rearranged, and deposited like icebergs on a slow alien sea. Every day on Pluto, sunlight hits the nitrogen ice and turns it to vapor. Every night, it refreezes. That daily breathing cycle generates winds. Those winds blow westward, opposite to Pluto's own rotation, because the heart is powerful enough to override the spin of the planet it sits on. The entire atmospheric circulation of a world is being driven by one geological feature. Here's the detail that quietly sits wrong. Astronomers had been watching that bright spot for 60 years before New Horizons arrived. 60 years of observing it slowly dimming and changing with no idea what it was. We were watching something breathe for 6 decades and didn't know it was alive. Number 8, Neptune, the planet that breaks its own rules. Neptune is the farthest planet in the solar system, 4.5 billion kilometers from the Sun. It receives 1/900th of the solar energy Earth gets. It should be cold, still, silent. The physics of distance say it should be the most boring planet we have. Its winds hit 1,300 miles per hour. Sustained. Constant. Planets scale winds 5 times faster than Earth's strongest hurricane, screaming around a blue world that barely gets any sunlight. The coldest major planet in the solar system has the most violent atmosphere, and nobody has a complete explanation for why. Solar energy can't be driving this. Neptune is too far away. So Neptune must be generating its own heat. And it does. The planet radiates 2.6 times more energy outward than it receives from the Sun. Something inside Neptune is running hot. What exactly that is remains one of the genuinely open questions in planetary science. The winds also do something counterintuitive. Near Neptune's equator, they blow westward, backward relative to the planet's own rotation. At higher latitudes, they switch and blow eastward. The planet's atmosphere is fighting itself. Go deeper, and it gets stranger. Thousands of kilometers below the cloud tops, the pressure becomes so extreme that methane gets compressed until the carbon atoms are physically ripped free and forced into crystal structures. Diamonds. Actual diamonds, forming inside a planet's atmosphere, then slowly raining downward toward the core. Scientists at a particle accelerator in California recreated these conditions in 2017 and watched it happen in real time. The diamonds formed in under a nanosecond. What they fall onto is still theoretical. Some models suggest a deep layer of liquid diamond surrounding a solid core, an ocean of diamond at the bottom of a planet. That part is still inference. The diamonds themselves are real. When Voyager 2 flew past Neptune in 1989, it found a storm the size of Earth in the southern hemisphere. Dark, oval, enormous. 5 years later, Hubble looked and it was gone. A new one had appeared somewhere else. Unlike Jupiter's Great Red Spot, Neptune's storms don't stay. They come and go like weather, except the weather is continental in scale, and the planet is 4.5 billion kilometers from anyone who could watch it. We visited Neptune exactly once. One spacecraft 4 hours, 36 years ago. Everything we know about one of our 8 planets came from a single afternoon. Number 7. Titan. A world with lakes, rain, and rivers, and none of it is water. You're standing on the surface of Titan, Saturn's largest moon. The ground is solid. The sky above you is a thick orange haze, dimly lit like permanent overcast at the end of a long day. Ahead of you, about 2 kilometers out, there's a shoreline, still liquid stretching to the horizon. River channels carved into the landscape leading down to it. If you didn't know better, you'd think you were somewhere on Earth. The temperature is negative 179 degrees Celsius. The lake is liquid methane. The rain that carved those channels was methane too. Marble-sized drops falling in slow motion through the dense atmosphere, drifting down at about the speed of a descending elevator. The waves on the surface of that sea max out at 1 centimeter tall, not 1 meter. 1 centimeter. The whole surface is nearly perfectly flat, barely disturbed. Every process that makes Earth feel familiar is running on Titan. Evaporation, cloud formation, rainfall, rivers cutting channels, lakes filling basins, seas with recognizable coastlines, the complete hydrological cycle operating in full right now. Just with methane instead of water, because at these temperatures, methane is what stays liquid. Water ice on Titan is as hard as a rock. It forms the mountains. The Huygens probe parachuted through Titan's atmosphere in January 2005, taking 2.5 hours to descend, and transmitted from the surface for 72 minutes before its battery died. The images showed a flat, pebble-strewn surface. The pebbles were water ice, rounded by flowing methane over long periods of time. A river had smoothed them, a methane river, on another world. In Titan's thick atmosphere and low gravity, a person wearing artificial wings could sustain flight through their own muscle power. Human-powered flight is physically possible there, in a way it isn't quite possible anywhere else. The atmosphere is dense enough, gravity low enough. The engineering would work, it looks like somewhere you could explore. The chemistry would kill you before you unclipped your helmet. Those are not the same thing, and the gap between them is what makes Titan unsettling. Number 6. Io, the volcano that never stops. If you took everything that makes a planet geologically alive, all the internal heat, all the tectonic energy, all the volcanic output, and concentrated it into a moon about the size of Earth's moon, you'd get something close to Io. Except Io is more extreme than that. At any given moment, up to 300 volcanoes are erupting simultaneously across Io's surface. 300. The plumes from the largest ones reach 500 kilometers into space, higher than the International Space Station orbits. The lava is so hot, over 1,600 degrees Celsius, that it matches conditions from Earth's early history more than 3 billion years ago. That type of eruption hasn't happened on Earth since before complex life existed. The surface temperature away from the vents averages negative 130 degrees. The vents themselves hit nearly 1,650 degrees. In between those two extremes, sulfur dioxide gas shoots into the thin atmosphere, freezes, and falls back as white snow. The ground is simultaneously covered in sulfur dioxide frost and surrounded by rivers of lava that would vaporize you in an instant. Io resurfaces itself completely every million years. Every impact crater gets buried under fresh volcanic material. The surface you'd be standing on is geologically brand new, constantly overwritten. The heat comes from being squeezed. Io is locked between Jupiter's colossal gravity on one side and the moon's Europa and Ganymede pulling from the other side. That gravitational tug-of-war flexes Io's entire interior on every orbit, stretching it, releasing it, stretching it again. The friction generates enough heat to power hundreds of volcanoes indefinitely. Io has been erupting at this level for approximately 4.5 billion years. There's one more detail. Io's constant volcanic output shoots sulfur and oxygen ions into Jupiter's magnetic field. This generates around 5 million amps of electrical current flowing between Io and Jupiter, a flux tube connecting moon to planet. That current produces a specific glowing auroral spot on Jupiter. You can actually see where Io's electricity hits Jupiter's atmosphere. The volcanoes were found by accident in 1979. An engineer named Linda Morabito was processing a routine navigation photo from Voyager 1 when she spotted something at the edge of the frame, a faint crescent shape arcing against the black of space. A plume. No one had predicted it. No one had expected it. Io had just been quietly erupting for 4.5 billion years, waiting for someone to look. Number 5. Saturn's hexagon. The storm with perfect geometry. Weather is supposed to be chaotic. Hurricanes spiral, vortices swirl. Even the most organized storm systems on Earth are fundamentally circular. The physics of rotating fluids on a spinning planet pushes everything toward curves. Straight edges don't survive. Corners don't exist in weather. Saturn's North Pole has a perfect hexagon. 6 equal sides, 6 equal angles. Each side nearly 14,500 kilometers long, roughly the distance from New York to Sydney. The total width of the structure is 32,000 kilometers, large enough to fit 2 Earths side by side inside it. Winds inside the jet stream blow at over 320 kilometers per hour. At the center, a hurricane with an eye 50 times larger than the average hurricane eye on Earth rotates steadily inside. It has been doing this without changing shape for at least 45 years. That's how far back our observations reach. We don't know how much longer before that. Voyager 1 captured data on the hexagon in 1981. When scientists saw it, many assumed it was an artifact, a processing error, a glitch in the data. It sat largely unexamined for 7 years. When someone finally took it seriously and confirmed it was real, the question of how it formed and why it stays stable became one of the stranger open problems in planetary science. Between 2012 and 2016, the interior of the hexagon changed color from a deep blue to a golden haze. Saturn's seasons shifted, sunlight drove new photochemistry, and the color of a continent-sized storm system transformed over 4 years. The geometry didn't change at all. Saturn's south pole has a large storm too. It looks like a normal hurricane, circular, spiraling, recognizable, no hexagon. 2 poles on the same planet, completely different structures, and no fully agreed upon explanation for why. In 2024, The James Webb Space Telescope looked at Saturn's ionosphere directly above the hexagon and found something nobody expected: a series of dark bead-like structures arranged in a ring and a faint star-shaped pattern extending from the pole outward. The scientists who found them said the features were completely unexpected and completely unexplained, and that they may be linked to the hexagon itself through processes in Saturn's atmosphere that haven't been characterized yet. The storm has been sitting there for decades. We keep finding new layers of it. Number 4. Enceladus. The moon venting its ocean into space. Enceladus is 500 kilometers across, roughly the size of Arizona. It orbits Saturn quietly, looks like a smooth white ball of ice, and by every reasonable measure should be geologically dead. Small icy moons that far from the sun don't have active interiors. They freeze solid and stay that way. Enceladus is shooting its interior into space. At the South Pole, 4 long fractures in the ice, tiger stripes, each one 135 kilometers long, are venting more than 100 individual geysers of water vapor and ice particles continuously into space. The plumes rise hundreds of kilometers. Some of the material escapes Enceladus's gravity entirely and drifts outward, gradually building Saturn's E-ring. A moon the size of Arizona is actively constructing one of Saturn's rings right now in real time. Cassini flew through those plumes, directly through them multiple times without landing, without drilling. It just dipped into the spray and measured what was in it. Water, molecular hydrogen, complex organic compounds, silica nanoparticles that can only form at hydrothermal temperatures, and phosphates, confirmed in 2023, the last major ingredient on the checklist. Carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. Every chemical building block associated with life present in the exhaust of a tiny ice moon. A 2025 reanalysis of Cassini's ice grain data found new complex organic molecules, large carbon-based compounds that form when simpler organics react under heat. The kind of chemistry that happens at hydrothermal vents on Earth's ocean floor, where no sunlight reaches and life builds itself from chemical energy alone. Here's where the honest line is. Ingredients are not life. Hydrothermal vents on a completely lifeless ocean floor would produce nearly identical chemistry. We cannot tell the difference from plume data alone, and anyone who says otherwise is getting ahead of the evidence. What we can say is this. Beneath the ice of a moon, smaller than Arizona, there is a liquid ocean kept warm by Saturn's gravity. There is heat from hydrothermal activity, there are the right chemicals, there is a plume system that is essentially handing us samples from that ocean for free, no drilling required. And there is no dedicated mission currently funded to go back. Number 3, Venus, the twin that became a nightmare. When the solar system formed, Venus and Earth started in nearly identical conditions. Same region of the disk, same raw materials, similar mass, similar size. For a window of time early in the solar system's history, Venus may have had liquid water oceans, a temperate climate, conditions that look almost familiar. Look at it now. The surface temperature is 467 degrees Celsius, not on the hot side, not near the equator, everywhere, at the poles, on the night side, at the bottom of valleys and the tops of the highest mountains. Venus is so thoroughly saturated with trapped heat that temperature variation across the entire planet is essentially zero, the most isothermal world in the solar system. It is always 467 degrees. The atmospheric pressure at the surface is 92 times Earth's. Standing there would feel like being 900 meters underwater, except the water is replaced with dense, hot carbon dioxide that near the surface behaves more like a liquid than a gas. Moving through it would feel like pushing through warm gelatin. The air itself is corrosive. Above, the clouds are concentrated sulfuric acid. It rains acid. The acid evaporates before it reaches the ground, rises back into the clouds, condenses, and rains again. A permanent self-sustaining loop of acid rain that never touches the surface and never stops cycling. The Soviet Union built spacecraft specifically to survive Venus. Their best lander, engineered like a deep-sea submersible, pressure-tested, heat-shielded, built to endure, lasted 127 minutes on the surface before the planet killed it. Venus likely had this coming. As the sun gradually brightened over billions of years, Venus's oceans began to evaporate. Water vapor is a greenhouse gas, So more vapor meant more warming, which meant more evaporation, which meant more warming. The feedback loop had no off switch. It ran to completion. The oceans are gone. The planet cooked itself and locked in the result. In 2023, scientists found that a volcanic vent photographed by the Magellan spacecraft in 1990 had visibly changed shape between two observation passes. Venus is still volcanically active. The planet is still generating heat from below, while the atmosphere traps everything above. There is technically one place on Venus where the temperature and pressure become briefly Earth-like, around 55 kilometers altitude in the cloud layer. The clouds there are sulfuric acid, but the numbers are survivable. It's the one place on Venus that isn't actively destroying everything inside it. This is what Earth looks like if the feedback loop wins. Not a slow decline, a complete transformation into something unrecognizable, locked in permanently. Number 2, Jupiter's Great Red Spot, the storm that outlived empires. You already know this one. The Great Red Spot, Jupiter's signature, the enormous red oval that's been in every image of Jupiter since photography existed. You've probably thought of it as stable, a permanent feature, ancient, fixed. It's just always there. In 2024, it started jiggling. Hubble watched the storm from December 2023 through March 2024 and documented something that had never been recorded before. The storm's shape oscillating on a 90-day cycle, shifting between rounder and more elongated and back again. The phrase one scientist used was jiggling like a bowl of gelatin. A storm that has existed for at least 150 years, possibly close to 200, started doing something new. And nobody knows what's causing it. Let the actual scale register for a moment. The storm right now is about 16,000 kilometers wide. Earth fits inside it with a room left over. When it was first carefully measured in the 1800s, it was closer to 40,000 kilometers across. 3 Earths. It has been shrinking continuously for over a century. And as it shrinks, the wind speeds at the outer edge have been accelerating. The perimeter winds now exceed 330 miles per hour, faster than the strongest tornadoes ever recorded on Earth. The Juno spacecraft measured the storm's depth using gravity. The Great Red Spot doesn't just sit on Jupiter's surface, it extends about 300 kilometers downward into the planet. 300 kilometers. The distance from New York to Boston, straight down into a gas giant. That's how deep the weather goes. The James Webb Space Telescope found warm patches of air in Jupiter's stratosphere directly above the storm, atmospheric layers that shouldn't be connected to weather happening hundreds of kilometers below. The storm is reaching up into places it has no business reaching. The color, that deep, unmistakable red, has never been explained. After decades of observation, multiple spacecraft, and generations of scientists, nobody has confirmed what makes it that color. Several competing explanations exist. None is settled. And a study published in 2024 found that the storm we've been watching for 150 years may have only formed around 1831. An earlier spot, observed by astronomers from 1665 to 1713, likely died. A gap of over a century. Then a new one formed. The thing we've been tracking, naming, photographing, and arguing about, it may be a different storm than the one Giovanni Cassini watched in the 1600s. The most famous feature on the most studied planet in the solar system is younger than assumed, actively shrinking, recently started behaving differently, and is still red, for reasons no one can confirm. Number 1. The Carrington Event. The sun already did this to us. September 1st, 1859. An amateur astronomer named Richard Carrington was sketching sunspots in his private observatory outside London when something erupted on the sun's surface. A point of white light so bright it temporarily blinded him. He watched it fade over about 5 minutes, noted the time carefully, and wrote it down. 17.6 hours later, a wall of magnetized plasma hit Earth. A coronal mass ejection, a cloud of charged particles expelled from the sun, normally takes several days to cross the 150 million kilometers between the sun and Earth. This one did it in 17.6 hours. It had been cleared a path by a smaller eruption days earlier, and it traveled at a speed that made the crossing in less than a day. The auroras that night reached near Panama. People in the northeastern United States read newspaper headlines by the light from the sky. Gold miners in the Rocky Mountains woke up and started making breakfast, assuming it was dawn. A Swedish scientist in a region considered too far south for auroras watched them appear overhead. The telegraph network, the only large-scale electrical system on Earth in 1859, failed globally. Machines sparked. Operators were shocked through their equipment. Papers caught fire from the electrical arcs at the contacts. Then some operators, curious, disconnected their batteries entirely and tried sending messages anyway. They could still communicate. The induced current from the storm was strong enough to power the telegraph lines on its own. Now, hold that image and replace the telegraph network with everything that runs your life. The power grid, GPS satellites, internet infrastructure, air traffic control, hospital equipment, banking systems. Every piece of technology that keeps modern civilization functioning runs on electricity and is connected to systems that are exposed to Earth's magnetic environment. A Carrington-class event today would drive currents through high-voltage transformers that they were never designed to handle. Transformers would fail. The grid would go down in cascades. High-voltage transformers are large, custom-built, and take between 1 and 3 years to manufacture and replace under normal conditions. There aren't large stockpiles of spares. Lloyd's of London modeled the economic impact of a modern Carrington-scale event at somewhere between $600 billion and $2.6 trillion. Those are modeled estimates, not certainties, but they're based on real engineering assessments of real infrastructure vulnerabilities. On July 23, 2012, a coronal mass ejection erupted from the sun that scientists later confirmed was at least as powerful as the 1859 event. The Stereo A spacecraft was in the right position to record it directly as it passed. It was a Carrington-class eruption, fully documented. It missed Earth by 9 days of orbital position. If it had erupted 1 week earlier, Earth would have been directly in the path. The warning system currently in place is a satellite called DSCOVAR, positioned about 1.5 million kilometers from Earth, roughly 1% of the distance to the Sun. When a coronal mass ejection reaches DSCOVAR, it transmits an alert. That gives us approximately 30 to 60 minutes before the wave hits Earth. 30 to 60 minutes. While you're at work. While you're asleep. While everything you rely on is running normally with no indication anything is wrong. The Sun fires these without a schedule. We are currently near the peak of the Sun's 11-year activity cycle, the most active phase when eruptions are most likely. We have been through solar maximums before. We will go through more. The last time a Carrington-class event hit us, the worst it could do was set some paper on fire and wake up some miners. The solar system isn't waiting for us to be ready.